Now, these graphing questions can be tricky. So the question it's asking is, what is the work done for the first 10 meters of travel? So when we talk about work, as you know, work is force times distance. And obviously, between 0 and 10 seconds, the distance is 10. But what about the force? Because there is an increasing force right here, right, from 0 to 10 seconds, and then you have a constant force for 10 seconds. And I think the best way to think about it is we know for the last 5 seconds, so from 5 to 10, the force is 10 newtons. We want to figure out what's the overall average force over the entire time. But for the from 1 to 5 seconds, if you think about it, what's the average? He went from 0 to 10, so his average is 5 newtons. So over the entire time, what is his average force? 10 plus 5 is 15. Average divided by 2. So the overall force, the average force is what you need to do in this case, would be 7.5 newtons. Once you know the force, you can multiply the distance and you can find what is the work done for the first 10 meters of travel. And then the second question, I don't have it typed here, but I do have it in my brain, is you're trying to find out at what point, when you're at 20 meters down here, at what point do you have the same kinetic energy, I think is what it's asking. And because the force is negative 10 down here, the place where you're going to find the same amount of kinetic energy, yeah, it's kinetic energy, how much kinetic energy, is going to be when you have 10. Now, the kinetic energy will be opposite in sign, but you will still have the same force. Because if you've got 10 down here, it doesn't show on the screen very well, and it's going to be the same right here at the flat line. So right here at 10 and right here at negative 10, you're going to have the same force, at least magnitude of force. So you're going to have the same amount of, it will be moving with the same kinetic energy.